All right, today's lesson is on 1.6 absolute value equations and inequalities. Absolute value. The absolute value of a number is the distance from 0 on a number line. The distance is always positive. So for example, if you have the absolute value of the number 2, that answer is going to be a positive 2. If you're looking at the number line, here's 0, here's 1, here's 2. So basically, 2 is 2 units from 0. That's why it's 2. If you have the absolute value of negative 2, that is also equal to 2. Because here's your number line, here's 0, here's negative 1, here's negative 2. Well, once again, you are 2 units from 0. So that's why it's going to be a positive 2. So absolute value is always positive. Now, understanding absolute values. So when you solve for x by isolating the absolute value expression on one side of the equation, you're going to have to check for your solution. So basically right here, you need to isolate the x. So now that says absolute value of x plus 2. So the opposite of plus 2 is minus 2. So I'm going to subtract 2 to both sides. So then 7 minus 2 is going to be a 5. And that equals the absolute value of x. Now, on here, when you have an absolute value of x, I can basically put a 5 there, and I can also put a negative 5 there. So what you're going to want to do is you're going to want to separate this. What I like to do is I see these lines, and then I separate it. I need one to be a positive, and I need one to be a negative. So I know x has to be a negative 5, and x has to be a positive 5. So I'm going to always separate it into the positive and into the negative. Now, always go back and check your answer. So plug in absolute value of negative 5, which is 5. 5 plus 2 is 7. Plug in 5. Absolute value of 5 is 5 plus 2 is 7. So right here, your answer is going to be negative 5 or positive 5. Another way you can see the answer written is like this, plus or minus 5. Next example. Notice how there's nothing in front of the absolute value or behind the absolute value. Because there's nothing in front of it or behind it, I can go in and I can start solving the problem. Now remember, you want a negative answer and a positive answer. So what I'm going to do is I'm going to make the 2x minus 3 equal a negative 1. And then I'm going to make the 2x minus 3 equal the positive 1. So always make it equal a negative and then make it equal a positive. Next, I'm going to go and I need to solve each of these separately. So right here, I'm going to go and I'm going to add 3 to both sides. So when I add 3 to both sides, I get 2x equals 2. And then I'm going to divide by 2 to both sides. So x equals a positive 1. Here, I'm going to add 3 to both sides. So 2x equals a 4. And then divide by 2. So x equals a positive 2. So your answer here is x is 1 and x is 2. If we go back and check our answer, 2 times 1 is 2, minus 3 is negative 1, and the absolute value of negative 1 is 1. When I plug in 2, 2 times 2 is 4, minus 3 is 1, absolute value of 1 is 1. Right here, get the absolute value by itself. I can't drop the absolute value. I need to get rid of that negative 5 first. So opposite of negative 5 is plus 5. So I'm going to first add 5 to both sides. So I have absolute value of 2x plus 1 equals 13. Now that the absolute value is by itself, I can go ahead and drop it. But if I drop it, once again, I need to have a negative side and I have to have a positive side. So I have to have a negative side and I have to have a positive side. So here I'm going to take the absolute value, so that's 2x plus 1. And I'm going to set equal to a negative 13. That's the negative side. And the positive side is 2x plus 1 equals a positive 13. Here I'm going to subtract 1 to both sides. Divide by 2. Here I'm going to subtract 1 to both sides. Divide by 2. So my answer is negative 7 and 6. And if you go back and you check your answer, it's going to work out. Another way to know is, can absolute value equal a positive number? Yes, it can. Example 1D, I have to isolate the absolute value. So I have to get rid of that times 3 on the outside. Do not try to distribute. These are not parentheses. So do not distribute the 3 on the outside. So I need to divide both sides by 3 to get rid of that 3 on the outside of the absolute values. So now I have absolute value 3x plus 1 absolute value equals 5. Once again, I need to have a negative side and I need a positive side. So here I'm going to let it equal the negative. So I have 3x plus 1 equals a negative 5. And here's the positive side. 3x plus 1 equals a positive 5. Here I'm going to subtract 1 to both sides and then divide by 3. So that answer is negative 2. Here I'm going to subtract 1 to both sides. And then when I divide by 3, that is actually a 4/3. So it's negative 2 and 4/3. Right here, I need to get the absolute value by itself. Now, don't distribute the 3. Now, remember, you have to get rid of any add or subtract on the side of the variable. So I need to get rid of this plus 8. So I'm going to subtract 8 to both sides. So I have 3 absolute value x plus 6 equals a negative 3. I now have to get rid of that times 3 on the outside. So I'm going to go ahead, I'm going to divide both sides by 3. So I have absolute value of x plus 6, absolute value equals negative 1. Before you think about dropping to positive and negative, will absolute value ever equal a negative number? No, it won't. So right here, absolute value cannot equal a negative. So even if you were to drop in, you would get a solution. When you go back and check your answers, you will never get it. It'll never work out. So right here, because absolute value will never equal a negative, this is going to be no solution. So I don't even have to solve it. I'm done with solving it. That is no solution. Right here, I need to solve for absolute value. So get rid of any add or subtract on the side of the variable. So I'm going to go and I'm going to add 1 to both sides. So now I have a 2. That is a 2. Absolute value 3x plus 5 equals a 10. I need to get rid of the 2 on the outside of the absolute value. So I'm going to go and divide everything by a 2. So now I have absolute value 3x plus 5 equals 5. Absolute value can equal a 5. So now I'm going to go ahead and I'm going to do the negative side and I'm going to do the positive side. So let's go ahead and let's set 3x plus 5 equal to negative 5 and 3x plus 5 equal to positive 5. On this case, I'm going to go and I'm going to subtract 5 to both sides. So 3x equals a negative 10. And then divide both sides by 3. So x equals a negative 10 over 3. On this side, I'm going to subtract 5 to both sides. So I get a 3x equals a 0. And then I'm going to divide by 3 to both sides. So x equals a 0. So the answer here is negative 10 over 3 and 0. Now go ahead and I want you guys to try these 4. Hit pause. I'm going to go ahead and I'm going to solve them now. So when you're done solving them, go ahead and hit play and make sure that you guys got the answers correct. So right here, I'm going to add 2. I need to have a negative side and a positive side. So this is going to be x equals a negative 8. And this is going to be x equals positive 8. So those are my answers there. I'm going to divide by 2 first because I need to get the absolute value all by itself. Now I can, absolute value will equal 2, so I have to do the negative, and then I have to do the positive. So now here, I'm going to have x plus 5 equals a negative 2. X plus 5 equals a positive 2. Subtract 5 to both sides, so I get a negative 7 here. And I get a negative 3 here. So those are the answers there. Here I'm going to subtract 8 to both sides. Now 2x plus 1 equals negative 7. Once again, absolute value will never give you a negative number. So automatically right here, I don't even need to solve this. This will be no solution. There's no answer I can ever plug in to give me a negative 7 when it comes out. On this one, I'm going to go and I'm going to add 2 to both sides. Divide by 2. And now I could get a 4 here. So I'm going to go and I'm going to do my negative and my positive. So now I'm going to let it equal the negative side and the positive side. So here I have a 3x plus a 1 equals a negative 5. 3x plus a 1 equals a positive 4. So when I subtract 1 to both sides here, I have 3x equals -5, and then divide both sides by 3, so I'm left with -5/3. On this side, I am subtracting a 1 to both sides, so I get a +3, and then when I divide by 3 to both sides, I get x equals 1. Next page. We're going to start applying absolute values to word problems. So the cruising speed for Kennedy's boat is 25 miles per hour. She plans to cruise at the speed for a distance of about 80 miles per plus or minus 10 miles, as she is not sure of the exact distance she still needs to go. So we have to go back to this. Distance is equal to rate times time. Now, the equation that is going to be modeled here is she's going 25 miles per hour. So that's going to be your variable. So we're going to do the absolute value of 25 miles per hour, right? And then the distance is 80. So I'm going to put a -80, and that's going to equal 10 because she needs to go within 10 miles. So equals 10. So I'm going to go ahead and I'm going to solve this. Now, since that's the equation, remember, you're going to need to have a negative side and a positive side. So right here, I'm going to set 2h minus 8, or actually 25h, not 2h. 25h minus 80, and that has to equal a -10. And then 25h minus 80 is going to equal a +10. In this case, I'm going to add 80 to both sides, so 25h equals a +70. And then when I divide both sides by 25, let's see, 70 divided by 25, that gives me 2.8. So here, h is going to be a 2.8. On this side, I'm going to add 80 to both sides, so 25h equals 90. And then when I divide by 25, 90 divided by 25, that equals 3.6. So here, h is equal to 3.6. So basically, the time has to be between 2.8 hours and 3.6 hours. So Kennedy will travel at least 2.8 hours and at most 3.6 hours. Now we're going to go ahead and try this, but now we're going to use 20 miles an hour. So right here it says, what is the minimum maximum time Kennedy will travel if she changes her cruising speed to 20? So now I'm going to do, now it's no longer 25, it's going to be a 20. So 20h minus 80 equals 10. I need to do a negative side and a positive side. So I have a 20h minus 80 equals a -10. 20h minus 80 equals a +10. Go ahead and add 80 to both sides. Divide by 20. So now that's 70 divided by 20, that equals 3.5. So here h is 3.5. On this side, I'm going to add 80 to both sides. So I have a 20h equals a 90, and then divide by 20. So 90 divided by 20, that equals 4.5. So now if her cruising speed changes to 20, it's going to be, so she's going slower because she was going 25 here, now she's going 20 here. So now her speed has to be, it's going to be 3.5 hours and 4.5 hours. So Kennedy will travel for at least 3.5 hours and at most 4.5 hours. Now, understanding absolute value inequalities when x is positive and a real number. Now, properties of absolute value inequalities when k is a positive real number. So right here, these are and problems because look at, they're all grouped together. This is known as an and problem. Now, the way I always remember this is this is the greater than symbol, okay? So since that's the oh no, that's less than, sorry. That makes an L. That makes an L for less than. So this is less than, I know that's not how you spell it, but that's the way I remember that. That's the less than symbol. This right here is the greater than symbol. So whenever you have the greater, those are going to be or graphs. Whenever you have the less than, those are going to be and graphs. Right here, the same thing. Look at that makes an L for less than. So less than. And then on this one, that is the greater than symbol because look, it makes a G for greater. Great or. So that tells you much less what the graph's going to look like. Is it going to be an and where the graph's going to each other, or is it or where they're going opposite of each other? So right here, that is the less than symbol. That makes an L for less than. Okay, so that's the less than symbol. So I know that the graph has to be facing each other. Now, when you are separating this to the positives and the negatives, what happens is this is going to stay the same. So for, let me see, negative, positive. So the positive, this is going to stay the same. It's going to be like this. But when you're doing the negative symbol, you have to basically flip the inequality. So put X and I'm going to put a -3, but now that inequality is going to change like that. So when you graph this, here's 0, here's 3 on this side, here's -3 on this side. At -3, it's going to be an open circle, and look at the arrow. The arrow is going towards the right. Right here at 3, it's going to be open, and the arrow is going to the left. This is an and graph right here. Now, the way the solution is written is you put an X in the middle. I'm going to put the bigger number on the right side, which is a 3. I'm going to put the -3 on the left side. Now, between right here, the X and the 3, it has to look like this. The symbol is actually going to be the same. On the and, the symbols need to be the same. Right here, too, look. If you're looking at this, look at the alligators eating the X between the X and the -3. This one, that is the great or symbol. That is the great or symbol. So this means that the graph has to go opposite directions. So once again, I'm going to have a negative side and I'm going to have a positive side. Leave the positive alone. But when you're doing the negative, you're going to make it equal the negative value, but the inequality symbol flips. So here's -3, here's +3. At -3, it's open, and look at the arrow. The arrow is going to the left. Right here, it's going to be an open at 3, and the arrow is going to the right. Because they were going opposite directions, this is an or. Now, I can't say right now that that's the less than symbol. It is a less than symbol, but before you can tell if it's like an and or an or, you have to isolate the absolute value. Like right here, the absolute value is all by itself. There's nothing in front of it behind it. Nothing in front of it behind it. But right here, I have that -6 there. So you need to move that -6 first. So I'm going to go and I'm going to add 6 to both sides. So I have absolute value 2x plus 1. Absolute value is less than or equal to 11. Now I can say that's an and. Okay, that's a less than symbol. So I know that's going to be an and graph. So the and graph has to look like this. I'm still going to do my negative and my positive. The positive, you're going to leave it alone. So that's just 2x plus 1 is less than or equal to 11. But on the negative, when you make it equal to -11, you need to flip the inequality symbol. So this is going to be a 2x plus 1. But instead of the less than symbol, it's a greater than symbol. And then that's going to equal the negative value. I'm going to add 1 to both sides. Oh no, subtract 1, sorry. Subtract 1, and then divide by 2. On this side, I'm going to subtract 1, and I'm going to divide by 2. And remember, the and symbol has to look like this. So I have to have a -6, and I have to have a +5. They are both closed circles because the line's on the bottom. Both closed circles because the line's on the bottom. At -6, the arrow is going to the right. At +5, the arrow is going to the left. Now, the way you're going to write your answer, though, you're going to have x in the middle. You're going to have 5 on the right side, -6 on the left side. Between the x and the 5, your alligator has to equal the 5, or has to eat the 5. This inequality symbol has to be the same. They have to go the same direction on the and. You can't have one go one way and one go the other way. Do not say this is a greater than symbol. You need to isolate the absolute value first. So I'm going to go ahead and I'm going to -4 to both sides first. And then I'm going to divide by 3 to both sides. Now I can go ahead and I can write my negative and my positive. I'll put the negative on the left side and I'll put the positive on the right side. So the positive, leave it alone. On the negative, I have to flip the inequality symbol and make it equal the negative value. Right here, I'm going to add 1 to both sides and then divide by 2. And oh yeah, and right here, that is the greater symbol. You look at the inequality once the absolute value is isolated. So I know that this graph has to look like this, where they're going opposite directions, and I need to keep the solution separate. Here, I'm going to add 1. That's going to be a -2. Then I'm going to divide by 2. There's a -1. So here's -1. Here's +2. At -1, it's an open because there's no line on the bottom and the arrow's pointing to the left. Right here, it's open at 2 and the arrow's pointing to the right. And then you can go ahead and leave your answer like that and just put the word or in the middle. Now go ahead and hit pause. And I want you guys solving the bottom 4, or the bottom 2 right here. Okay, go ahead and solve the bottom 2. And then go ahead and hit play. I'm going to go ahead and solve them right now. Absolute value is isolated. So this is going to be the great or. I'm going to let it equal a positive and a negative. When it's the negative, I have to flip it. I'm going to subtract 3, divide by 2, subtract 3, divide by 2. So here's -6, here's +3. That is closed at -6 and going to the left. That is closed at 3 and going to the right. The answer needs to be written separately. And there we go. Right here, I need to isolate the absolute value, so I'm going to go and subtract 3 to both sides. That is the less than symbol. That is the less than symbol. So when it's positive, it's going to stay the same. At negative, I need to change the inequality symbol and equal a -9. Here I'm going to add 5 to both sides. So that's going to be 14 divided by 2. So that's going to be a 7. On this side, I'm going to add by 5 to both sides. So it's going to be a -4. And then divide by 2. So that gives me a -2. So here's -2. Here's +7. That's open. And it's going to the right. That's open and going to the left. Now, and needs to be grouped together. So you're going to put the x in the middle, -2 on the left side, +7 on the right side. Right here at x and 7, it has to be the less than symbol, so they're both the less than symbols. Now, what happens when the k is a negative? We're going to go ahead and we're going to solve these right here. Something's going to happen when they're negatives. Notice how all of these, they all had a positive, they all equaled positive. Something's going to happen when the absolute value equals negative. Now, yes, absolute value cannot give you a negative number. However, we now are not changing, that's not an equal sign, that's an inequality symbol. So that's what I need you guys to realize right here. That's a negative number. You can still solve it though, because it's an absolute, it's a inequality now, not an equal sign. So basically, on this one, that is the greater than symbol, okay? On the greater than symbol, this has to be a positive number. So the positive number is going to be greater than or equal to a -2, because think about it. Whenever you're taking the absolute value is always positive. Well, this positive number will always be greater than or equal to -2. So this is always going to be true. You're thinking of it logically. Absolute value, this has to be a positive number. It doesn't matter what number it is, it's going to be positive. Even if it's a number 0, this number is always going to be greater than or equal to -2. So since that's always true, every single number you ever plug in will always be true. This is going to be infinitely many solutions. Or sometimes they say all real numbers. Now, on this one, absolute value, this right here, and once again, this is going to be a negative right here. Absolute value always has to be positive. So whatever this is, it's going to be a positive. Will this positive ever be less than or equal to -1? That is not a true statement. This is never true. So because this is never true, there's no number I can ever plug in here to make this any number true. So the number line is going to be empty and it's going to be no solution. So think of it logically. Absolute value has to be a positive. Will a positive number ever be less than or equal to -1? No, it will not. Writing an absolute value inequality. Okay, so right here. Members of the debate team are traveling to a tournament where they will stay in a hotel for 4 nights. The hotel cost for each member must be within $20 of the $175 hotel budget. If Hotel A costs $50 per night, Hotel B costs $45 per night, and Hotel C costs $50 per night, which hotel can they stay at to stay within their budget? So we're going to write an inequality to represent the situation. So I'm going to go ahead and I'm going to let C equal the cost of a hotel for 1 night. Now it says you're going to stay there for 4 nights, okay? So 4 nights, I'm going to take 4 and I'm going to multiply it to C. Now the budget is 175. So the 4 nights times whatever the cost is, I'm going to take that and make sure it has to be in that 175 range. I'm going to set that less than or equal to, the budget has to be within $20. All right, now we're going to solve this. The absolute value is already isolated. So I'm going to go and I'm going to do the negative and I'm going to do the positive. So I'm going to set 4C minus 175, because this is the negative, I need to equal -20, and then equality symbol is going to flip. On the positive, I just leave it alone. Here I'm going to add 175, so -20 plus 175, that is equal to 155. I'm going to divide both sides by 4. So 155 divided by 4, that equals 38.75. So the cost here will be 38.75. That's the low one. Now on the high end, I'm going to add 175 to both sides. So I get 195, and then divide that by 4. 195 divided by 4, that equals 48.75. So they can stay at a hotel that is between this budget right here. They can spend at least $38.75 per night, and at most $48.75 per night. So let's see the hotels. Remember, Hotel A was 40 bucks, Hotel B was 45, but Hotel C is 50. 50 is not in this range. So they can only stay at Hotel A or B. They can choose Hotel A or Hotel B. I want you guys to go ahead and I want you guys to try number 4. Hit pause. I'm going to go ahead and solve it right now. If the debate team increases their limit to $200, so now instead of 175, I'm going to put 200 there, and plus or minus still, it's going to still stay at $20. So let's go ahead and let's see. That's going to be 4C minus 200, and it's still less than or equal to 20. I'm going to do my negative and my positive. Positive, you just leave it alone. But on negative, I'm going to make it equal to negative 20, but I have to flip that inequality symbol. I'm going to add 200, divide by 4, and that actually is 45. I'm going to add 200, divide by 4, and that's going to be a 55. Now the question says, would they be able to stay at Hotel D for 55 a night? Well, look right here. The highest is 55. So yeah, they can stay at Hotel D now. They can spend at least 45 and at most, because it's equal to 55 per night. So therefore, they can stay at Hotel D. All right. Concept summary. This is everything that these notes covered. To solve an absolute value equation, you need to isolate the absolute value expression, then write 2 equations, a positive and a negative. So right here, I need to isolate the absolute value. So I'm going to go ahead and divide by 2 to both sides. So that's the value of x minus 17 equals 18. Absolute value will equal an 18. So you have to separate it into a negative and a positive. So here I'm going to write x minus 17 equals the negative 18. In the positive, you just keep it positive. Right here, I'm going to add 17 to both sides. So if I, actually divide by 2, that should have been a 9 here, sorry. I forgot to divide 2 to the right side. And look, it equaled the negative 9 and the positive 9. So here when I add 17, x equals a positive 8. Here when I add 17, x equals a 26. Now, if they ask you to graph this on a number line, on the number line, you have to show me where 8 is and where 26 is. Because there's no arrows, you're not doing any shading. It's just basically the closed points. That's it. X equals 8 and x equals 26. There is no arrows, so I don't want to see any shading. Here we have some arrows, so we are going to be doing shading. If an absolute value inequality uses less than equal to points at the variable, and the inequality uses and, if an absolute value inequality uses the greater or greater than equal to points, that's going to be the or. So right here, what I'm going to do is that is an and. That is an and, because that's the less than symbol. I'm going to go in, I'm going to write the negative and the positive. On the negative, you make it a -1 and you flip the inequality symbol. On the positive, you leave it alone. So here's -1, here's +1. They're both closed because they have the line on the bottom. At 1, it's going to the left. Right here, it's going to the right. And on and, you write it like this. Oh, actually, positive's on the right side. Inequality symbols have to be the same. Right here, that is a greater symbol. Let's make it equal to negative. At the negative, I flip the inequality symbol, make a -2. On the positive, you leave it alone. That is an open circle and going to the left. That is an open circle going to the right. You need to keep these separate. So this is x is less than -2 or x is greater than +2. You keep them separate. All right, last page. Why does the solution of an absolute value equation or inequality typically result in a pair of equations or inequalities? One equation or inequality represents when the quantity inside the absolute value symbol is positive. The other equation or inequality represents the case when the quantity is negative. Because remember, absolute value always comes out to be positive. So you have a positive side and a negative side. How is solving an absolute value in equation similar to solving an equation that does not involve absolute values? And how is it different? You are using inverse operations and math properties to solve equations and absolute value equations. They are different because absolute value requires two equations to solve. Describe how you would explain to another student why absolute value or a number line cannot be negative. Well, remember, absolute value can never be a negative value because it's a distance from zero. You can't be negative distance from zero. The absolute value of a quantity represents the distance from zero on a number line. The distance is always positive. Yumiko solved the absolute value of x is greater than 5 by solving absolute value of x is greater than -5 and absolute value of x is less than 5. Explain the error he made. Well, remember when you're doing the positive, you leave it alone. So right there, right here, when you're doing the positive, he should have left it like this. And then when he's doing the negative, that's when you change it to a -5 and you change the inequality symbol. So this is what he should have solved. All right, let's go ahead and let's solve these problems. Go ahead and hit pause and solve these and then hit play. I'll go ahead and I'll solve them now. Isolate the absolute value, so I'm going to subtract 3 to both sides. Absolute value can equal a 2. So right here, I'm going to let it equal the negative value and the positive value. And then that's it. On here, that's fine. Absolute value is already isolated, so I'm going to let 2x plus, or actually minus, sorry, leave it the same. 2x minus 8 equal positive 16, and then set 2x minus 8 equal to the negative 16. Add 8 to both sides, that's going to be a 24. Divide by 2, so that's 12. So 12 is one of the answers. Add 8 to both sides, divide by 2, so negative 4. So here, x equals a negative 4 and a positive 12. On this one, I'm going to say 3x minus 6. I need to flip it because I'm going to make that equal to negative. And then here's the positive. And this is an or symbol because that's the greater symbol. So I need to keep them separate. So add 6 to both sides, divide by 3. Add 6 to both sides, divide by 3. So this is negative 1, this is positive 5. That's going to the left, that's going to the right. And this is your answer. That's the less than symbol. So I'm going to let it equal the negative value. So let me flip that first. And then here's the positive value. I'm going to add 12. Divide by 4. That's a negative 2. Add 12. Divide by 4. That's going to give me an 8. So here's negative 2. Here's 8. They're both closed. And negative 2 is going to the right. And 8 is going to the left. I knew it was going to go towards each other. So x goes in the middle. Negative 2 goes on the left side. 8 goes on the right side. And it's going to stay that inequality symbol. On a road trip, Andrew plans to use his cruise control for 125 miles plus or minus 20 miles. So that's going to be the difference. So that's what it needs to be equal to. Write and solve an equation to find the minimum and maximum number of hours for Andrew's road trip if he sets his cruise control at 50 miles an hour. So he's setting it at 50. So it's going to 50 times whatever the time is. And it's going to be 125 miles of distance. And I'm going to set that equal to 20. So let's see, I get a 50h minus 125 equals a negative 20. 50h minus 125 equals a positive 20. So I have a negative 20 plus 125. That gives me a 105. I'm going to divide that by 50, and I get 2.1. Here I'm going to add 125 to both sides, so that's going to be a 145. 145 divided by 50, that equals 2.9. So Andrew will spend a minimum of 2.1 hours and a maximum of 2.9 hours driving. And that concludes our notes.